Well, last time we solved a problem when a bulb is connected to a voltage source, what will be the power consumed, and when the voltage is reduced, what will be the power that will be consumed. Now we'll connect two bulbs of different rating to the in parallel to the voltage source. Here you can see two bulbs connected in parallel, and these are the ratings that we discussed last time. Now I'll explain briefly, because those who have not seen our previous video, it will be helpful for them. This is the rating of the bulb. It is given that it is 220 volt 100 watt, and this bulb is 220 volt 60 watt. Now what is the meaning of this rating? This is the rating printed on the bulb or on the casing of the bulb, and it says that when this bulb will be connected to 220 volt supply, it will consume 100 watt. Okay, so if this is the bulb, if it will be connected to 220 volt, this is the bulb. If it will be connected to 220 volt, then it will consume 100 watt. And similarly, if this bulb will be connected to 220 volt, it will consume 60 watt. Now you can see that these two bulbs are connected to 220 volt. So voltage across this bulb is 220 volt, so it will consume 60 watt, and this bulb is also connected across the 220 volt, or voltage across this two terminals is 220 volt. They are directly connected across the battery. So now this will also consume 100 watt. Okay, so together they will consume 100 plus 60, that is 160 watt, and this bulb will be brighter because it is consuming more power than this bulb. Now if this voltage will be reduced to 110 volt, then what will be the power consumed by these two bulbs? This is the rating. Now how you can say how much power they will consume? That last time also we discussed, and that you can do by calculating the resistance, and two resistances in parallel will get the power consumed by these two. That is an exercise for you. You can do it. Now in this case, in the original case of 220 volt, we see that this will be brighter than this. Now if these two will be again connected in series across the 220 volt supply, then how much power they will consume, which one will be brighter? That will solve now. This is the circuit diagram. Here those two bulbs, 220 volt and 100 watt rating, and 220 volt 60 watt rating, they are connected in series. Now what will be the power consumption by these two? Which one will glow brighter? That we have to find out. What we can do? Now we have to calculate the resistance, which is not given. Okay, how to calculate the resistance? What is this rating that we just discussed? That when this, suppose this is the lamp. Okay, this is the lamp. That means when this bulb will be connected across the voltage source of 220 volt, then the power consumed by this bulb will be 100 watt. So from this information you can find out the resistance. We know the formula of power. P is equal to, we will use here this formula, V square divided by R. So from this formula we get R, that is equal to V square divided by P. Now putting in this formula, we calculate R, that is equal to V square. V is 220 square divided by P. P is how much? 100 watt. Now let us calculate this. Yes, we get it as 484 ohm. This is the resistance we have calculated from its rating. Similarly for this, we'll call it as R1. Similarly for this bulb, we will calculate R2. R2 is equal to V2, that is just similar to this case. Here if this bulb will be connected here and the 220 volt is supplied, then we'll get 60 watt. That means R2 is equal to 220 square divided by 60. Let us calculate how much we get. That is 839.67. Let us call it 7. So 839.7. Okay, R2 is this much and R1 is this much, and they are connected in series. Let us draw the equivalent circuit. This is the equivalent circuit. This one is now 484 ohm and this is 839.7 ohm, and this voltage is 220 volt. Now we have to calculate the power consumption in these two resistances. This is R1 and this is R2. What will be the power consumption? Now we have to calculate the equivalent resistance, because we have to calculate the current that is flowing through the circuit, and we will use I square R formula to find out the power consumed by these resistances. Or otherwise we can calculate the voltage drop across this and multiply with the current, or B square divided by R. That also we can calculate. Okay, let us calculate I. I is how much? This is current I. I is equal to V divided by R1 plus R2. R1 plus R2 is the equivalent resistance. That is equal to V is how much? 220 volt divided by R1 plus R2. R1 plus R2 how much? That is equal to 1323.7. That is how much? Let us calculate. So you get 0.166, this much ampere. So this much ampere is flowing through the circuit. Now power consumption in this resistance, let this be P1. So P1 is equal to I square R1. We'll apply this formula, I square R1, that is how much? I square, that is 0.166 square into R1 is into 484. Let us find out the value. 13.337. This is 13.337. It is equal to 13.337. This much watt. Similarly, P2 is how much? That is equal to I square R2. That is equal to 0.166 square into R2 is how much? 839. 839.7. That is equal to, let us calculate. That we get about 23.14. That is 23.14 watt. Okay, so which is consuming more power, P1 or P2? It is P2 that is consuming more power. So it is consuming 23.14 watt, and this one is consuming 13.3. Let this be 3 per watt. So we can see that which was actually 60 watt bulb, and now it is consuming more power than the 100 watt bulb. That is because the bulbs are connected in series. That means the resistances are connected in series. So which one was having the more resistance, and the voltage across it will be more. And moreover, from this formula you can see that this formula, if the resistance will be more, then the power consumption will be more, because the current is same in the circuit. But in case of parallel connection, from this formula the voltage is the same. The one is having low resistance that will consume more power, and in this case it is just the reverse, and the 100 watt bulb that will be less brighter than the 60 watt bulb. In the household you will find that the appliances are connected in parallel, so they will consume more energy. The bulbs and other household equipments, they are also rated for 220 volt. That means the for parallel connection, because in the household you will find the two conductors. This is positive or negative, you can say, or phase and neutral. In the AC case it is phase and neutral. So all the loads are connected like this between these two. These are connected in parallel, and the supply is from the utility supply, that is the supply from a power company, distribution company. So now we know that which one is consuming more and which one is consuming less. Here the main thing is that you have to calculate the resistance of the bulb from the rating, and the rating is specified for a given voltage. Manufacturer assume that you will connect to the 220 volt supply, and that is actually the voltage supply. In most of the countries there are one or two supply voltages. It is 220 volt or 110 volt or 230 volt. So this is the main philosophy behind the series and parallel connection. So one thing is that if these two bulbs, they will be connected to 440 volt, then what will happen? So you can see that the voltage across the bulbs are not the same, because their resistances are not the same. So the voltage distribution, if it will be V1 and this voltage V2, so V1 divided by V2, that is in the ratio of the resistances. The resistances are how much? That is 484. Its resistance is 484, and the others is 839. So the voltages are in the ratio of the resistances. So you can see that the voltage across this the one having the higher resistance will be more. That means if it will be 440, then this voltage will be more than 220 volt, and it will be less than 220 volt. For this bulb there will be no problem, but it is rated for 220 volt, and if it will be more than 220 volt, then it will definitely be brighter, but it will not last long. It will burn out soon. Okay, so that's all for now, and we'll discuss more next time.